Ever wondered how chemists predict exactly how much of a substance will react? Or why sometimes you have leftovers in a chemical reaction? Today, we're cracking the code on moles, stoichiometry, and limiting reagents. First, let's talk about the mole, and not the furry animal, but the chemistry kind. It's just a huge number, 6.022 times 10 to the power of 23 particles, known as Avogadro's number. Think of it as the chemist's dozen, but instead of 12, it's an astronomically large number. Why do we use it? Because atoms and molecules are too tiny to count individually, so we bundle them in moles, just like eggs come in cartons or fries come in bags. Remember, each element on the periodic table is different, meaning 1 mole of oxygen is not the same mass as 1 mole of uranium. We use this simple equation to convert moles to mass using the molar masses of the elements found on the periodic table. Now that we have moles, let's use them in stoichiometry, the math of chemistry. Imagine baking cookies. If your recipe calls for 2 cups of flour plus 1 egg to make 6 cookies, you can calculate how many cookies you get with 4 cups of flour and 2 eggs. Chemical reactions work the same way. Let's take a look at this chemical equation, for example. This equation tells us that 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. With stoichiometry, we can predict how much product we'll get from a given amount of reactant. Using the coefficients of the chemical equation, we can calculate quantities as long as we make sure units are consistent. Let's take a look at this other reaction now. And don't forget, we must use the balanced form of the chemical equation. In this case, we'll work with molecules. How many molecules of sulfur trioxide are needed to react with 500 molecules of ferric oxide to produce ferric sulfate? Let's try another one. For the reaction, potassium superoxide plus carbon dioxide producing potassium carbonate plus oxygen gas. How many moles of both products are formed when 7.33 moles of potassium superoxide react? Now let's add a mass conversion into the picture. Lead reacts with plumbic oxide and sulfuric acid to form lead sulfate and water. What mass of lead sulfate is produced when reacted with 30 grams of sulfuric acid? What if you run out of bread before using all your ham and cheese? You can't make more sandwiches, right? That's the idea behind the limiting reagent, the reactant that runs out first, stopping the reaction. The leftover ingredients, that's the excess reagent. Suppose you have 5 moles of aluminum and 4 moles of oxygen. Which one runs out first? By using stoichiometry, we determine that aluminum is the limiting reagent, meaning once it's gone, the reaction stops. Let's try another. Magnesium oxide plus hydrogen sulfide react to form magnesium sulfide and water. What is the limiting reagent, and And that's it. The magic of chemistry, decoded. Next time you mix ingredients, whether in the kitchen or the lab, remember, chemistry is just a recipe with a bit of math. If you enjoyed this, like, subscribe, and drop your chemistry questions in the comments below.